Hi everyone! In this video, we'll go over what's the difference between empirical formula and molecular formula of a compound. After that, we'll do some examples to learn how to find empirical formula for mass percent of elements in a compound and how to find molecular formula when given the molar mass of the compound. So let's get started. Empirical formula of a compound is the formula that shows the ratio of elements present in the compound. In contrast, we have molecular formula, which is the formula that shows the actual numbers of atoms of each element that makes up the molecule. Let's look at an example. Let's say we have glucose, and we know glucose is C6H12O6. The empirical formula for glucose is going to be CH2O. We can see that this formula just shows the ratio of the number of atoms of carbon and hydrogen and oxygen in a glucose molecule is 1 to 2 to 1. It doesn't actually show how many atoms of carbon, how many atoms of hydrogen, or how many atoms of oxygen actually present in a molecule of glucose. Meanwhile, we have the molecular formula of glucose. That's going to be C6H12O6. In this formula, it shows that one glucose molecule consists of 6 carbon, 12 hydrogen, and 6 oxygen atoms. So now that we've gone over the definitions as well as an example, let's look at some example problems to learn how to solve for empirical and molecular formulas of a compound. Problem 1. What is the empirical formula of a molecule containing 65.6% carbon, 5.5% hydrogen, and 29.0% oxygen? So, in order to find empirical formula, when given the mass percent of each element in the compound, first we need to find the number of moles of each element in 100 grams of that compound. So, in 100 grams of a compound, there will be 65.5 grams of carbon, and that is because in the prompt we're given that the mass percent of carbon in this compound is 65.5%, and so to find the mass of carbon in 100 grams of this compound, I'm just going to take 65.5% times 100 grams, and that's how I get 65.5 grams of carbon. Similarly, we can find that there are 5.5 grams of hydrogen and 29.0 grams of oxygen in 100 grams of this compound. So now that we have the mass of each compound, let's calculate the moles. So to find the moles of carbon, I'm just going to take the mass of carbon divided by the molar mass of carbon. Substituting numbers in, that's going to be 65.5 grams divided by 12.01 grams per mole, and that's going to give me 5.45 moles of carbon. Similarly, to find the moles of hydrogen, I'm just going to take mass of hydrogen divided by the molar mass of hydrogen, and that's going to be 5.5 grams divided by 1.008 grams per mole, and that's going to give me 5.46 moles of hydrogen. Lastly, let's calculate the moles of oxygen. That's going to be mass of oxygen divided by molar mass of oxygen. That's going to be 29.0 grams divided by 16 grams per mole, and we're going to get 1.12 moles of oxygen. In step 2, we need to divide the number of moles of each element by the smallest number of moles. First of all, we need to identify the smallest number of moles among the free number of moles that we just calculated. Here we can see that the number of moles of oxygen, 1.12, is the smallest, and that is because it's smaller than 5.45 moles of carbon and 5.46 moles of hydrogen. So once we identified that, we're just going to divide all of them by 1.12 moles. And that's going to give me the mole ratio of carbon is 5, mole ratio of hydrogen is 5, and mole ratio of oxygen is 1. Lastly, let's write the empirical formula from the mole ratio that we calculated in step 2. So from the mole ratio that we calculate in step 2, we can write the empirical formula of this compound. That's going to be C5H5O. That is the empirical formula of this compound and the answer to this question. Moving on, let's look at an example on how to find molecular formula of a compound when given the molar mass and the empirical formula. Problem 2. A compound has an empirical formula of C2H8N, and its molar mass is 46 grams per mole. What is the compound's molecular formula? So, to find the molecular formula when given the empirical formula as well as the molar mass of the compound, first we need to calculate the molar mass based on the empirical formula. So, the empirical formula is C2H8N. So to find the molar mass of C2H8N, I'm just going to take 2 times the molar mass of carbon plus 8 times the molar mass of hydrogen plus the molar mass of nitrogen. And that's going to be 2 times 12.01 plus 8 times 1.008 plus 14.01. And that's going to give me 46.094 grams per mole. Next, in step 2, we're going to divide the molar mass of the compound given in the prompt by the molar mass based on empirical formula that we just calculated earlier. That's going to be 46 grams per mole as given in the prompt divided by 46.094 grams per mole that we calculated from step 1, and that's going to give us the molar mass ratio of roughly 1. Now that we got the molar mass ratio, we're going to multiply all subscripts in the empirical formula by the molar mass ratio to get the molecular formula. So in the empirical formula C2H8N1, the subscripts is the number 2, 8, and 1. So to find the molecular formula, I'm just going to times all of the subscripts by the molar mass ratio of 1 that we found in step 2. And that's going to give us C2H8N. That is the molecular formula of this compound. So we can see for this compound, the molecular formula and the empirical formula are identical. Let's look at another example. Problem 3. A compound has an empirical formula of CFBrO and its molar mass is 254.7 grams per mole. What is this compound's molecular formula? Similarly, we're going to do the 3 steps that we did for problem 2. So, to find the molecular formula when given the empirical formula and the molar mass of the compound, first we calculate the molar mass based on the empirical formula. So the molar mass of CFBrO, that's going to be the molar mass of carbon plus the molar mass of fluoride plus the molar mass of bromine plus the molar mass of oxygen. That's going to be 12.01 plus 19 plus 79.9 plus 16. And that's going to give us 126.91 grams per mole. Next, we're going to find the molar mass ratio by dividing the molar mass of the compound by the molar mass based on empirical formula that we calculated in step 1. And that's going to be 254.7 grams per mole as given in the prompt, divided by 126.91 grams per mole that we calculated in step 1. And that's going to give us 2. Lastly, in step 3, we're going to multiply all subscripts in the empirical formula by the molar mass ratio that we just found in step 2 to get the molecular formula of this compound. So in the empirical formula for this compound, the subscripts for all elements in the compound is 1. And so to find the molecular formula, I'm going to times all the subscripts by 2. And that's going to give C2F2Br2O2. That is going to be the molecular formula of this compound.